Hi, my name is Sophie Luo, and this is my computer hardware component. Today we're talking about the GPU. So what is it? The GPU, or the graphics processing unit, is responsible for rendering images. Everything you're seeing right now is being rendered by your GPU. And this was basically like the start for like videos and animations and game development. And it basically accelerates the process of rendering graphics in like your video games, your Minecraft, your Fortnite. What else do people play? Valorant? I don't know. And it's basically like everything you're watching right now. So this is the GPU. When people think of GPU, they think of like the graphics card, which is the one with like the big fan thing. But no, the GPU is like this tiny little chip inside the middle. The graphics card basically like encases it. Yeah. So why was it created? So the problem was everything was inefficient and the CPU was being overloaded. This before the graphics card was created, the CPU was basically the graphics, like the graphics card. Um, it was overloaded because it was like such old technology that it couldn't like handle everything that people wanted it to. It was slow, the graphics were simple, everything was pixels on a screen, and just game performance was terrible. So yeah, again, before the GPU was dot matrix screens. So dot matrix screens were like the digital displays that you see now that like you mainly see on like road signs. Um, and they were like individual, it's like a grid of individual dots that could be lit in form like text, images, symbols, and then there were basically like LED, LCD, or OLED. And um there were also vector and raster displays, which were also um on a grid pattern. Vector used mathematical equations to create like scalable images. Like if you like scaled them up, they would not lose the quality and be pixely, but raster could not be resized. They became pixelated very easily because they were on that grid system. And so when was the GPU like when did people want to bring that into like fruition? There was this 3D imaging project pitched in the 90s to generate like a single pixel on a screen with a single processor. Like each one had a single processor, and they're trying to get many pixels in a very short amount of time. So that's how the GPU was birthed, basically. The GPU combined everything into one programmable chip, meaning they used like a existing rendering software, like a rendering engine, and they used a lighting engine and a graphics controller, and they put it all in this programmable chip. Because before it was not programmable. It was very like it was just very basic. So what if there was no GPU? Overall, the computer would not stand without the GPU. It'd be very sad, very stop motion-y, very pixely. You would not be happy. It would be very limited in its capacity. Like you would not be able to use your basic tools smoothly. Like your mouse would be very shaky. Your like basic desktop programs would not work. Documents would not flow. They would not be as smooth as they are. And who would compensate? Oh my God, the CPU. The CPU you would just take over just like before, and it would be overloaded again, and it would not be a pretty fun time. The limitations are, yeah, we could not use basic web documents. We can't we can't use modern video formats because the CPU would just it would not be up to that standard. Basically, it's like not like it would be non-existent for our modern 3D games and be horrible for like classic 2D games as well for like I would say like Pokemon, like the Pokemon franchise, whatever. That would not look good. It doesn't look amazing now. It wouldn't look good if we didn't have a GPU. So let's talk about the size and evolution. People talk about GPU sizes and they usually think about like the graphics card sizes, so like the one with the three fans on it. But no, we're talking about the actual like silicon chip inside the graphics card, which are around like 200 to 300 millimeters. It's a square. Um, So we can talk about the early models. The early models were like they had a direct relationship between the amount of transistors and the size that they were inside the computer. So in like the late 90s, 2000s, the die we're talking about is like the actual face of the chip. It's about like 100 to 150 millimeters squared. And the big brands were like NVIDIA, ATI. NVIDIA really just is very prominent here. So it was basically like the first 3D accelerator. The number of transistors were in the millions, and it took up a lot of space in the computer model. So then in the mid 2000s to like the mid 2010s, the die size, again, the face, went up to like 250 to 500. So again, we're seeing this direct relationship with the number of transistors and the size of the die and the amount of space that it takes up. That's around like in the billions. We're gonna see that on the next slide. And the physical size got larger. And then in the late 2010s to present day, die size went to around the same size, like 250 to 250 to 450. So in the late 2010s to the present day, we see that it's like around the same size in the face, but we can see that there are way more transistors and there was not like increase in size. And this is because we were able to shrink the nodes. Basically, the nodes are how it determines how small the transistors can be made. By shrinking the nodes, we can increase the amount of transistors. There was a big change in how they created these silicon pieces, these monolithic dies. Basically, the monolithic die is just one big piece of silicon. Um, they stopped doing that. So the chiplet design allowed them to like cut cost in manufacturing and allowed them to use smaller dies and connect them together. Creators and companies that were really pushing for evolution and manufacturing of these GPUs were in 1996, Voodoo, which had 1 million transistors and the nodes were in the 500s. They were small and simple. And then NVIDIA took the next two with their 2012 model that had 7.1 billion transistors. And you see how the number dropped from 500 to 28. They shrank their nodes, increasing the number of transistors that they have. So this was rapid growth, and they pushed the limits of the monolithic die. This was before the chiplet design where they took multiple and put them together. This was still one big piece of silicon. And then in 2022, NVIDIA made another um piece that had 45.9 billion transistors. And again, the size of the nodes shrank, increasing stability. They're shrinking the size. There's less nodes, more transistors. And then again, in 2022, Navi had a 58 billion transistor with like a 5 or 6 size node. The size went up, but it's still they increased the amount of transistors that they have. They were using new strategies, using smaller pieces, the chiplets. So let's talk about the end of life. Like, what do you do with your old parts, with your old GPUs, with your old computer like hardware components? Obviously, you reuse and resell, which we can just hope that people would want like a older model. It's the highest impact and avoids waste entirely instead of like displacing demand for new products. We can repurpose, use it in a secondary, less demanding PC. These can just be hand-me-downs. We can recycle in certified e-waste facilities, which allows for safe recovery of these valuable materials. Again, everything's being sent back to the earth. Uh, you could find local hazardous waste disposal options if the other options are not available, but you never throw it in regular trash because that would contaminate the environment and waste finite resources. These are my references. Thank you so much for watching and listening to me talk about the GPU.